So hello, everyone, and thank you all for coming to my talk on building better components, aka component code craftsmanship, which is kind of hard to say, so I'm sorry. Kind of a tongue twister, so try to say that 3 times fast. I'm not going to. My name is Dianne, and I work for a small product company in Baltimore called AlloView, where we build financial software for school districts. I've been a professional developer for about 3 years now, having switched over from a career in finance and accounting. And I want to begin my talk by painting you a picture of what it was like for me when I was first starting out. I worked in an Ember code base that was written by back-end developers who had very little Ember or even front-end experience. As a result, we didn't follow established Ember patterns. There was jQuery everywhere, and we had a lot of redundant code. We also had these monster components that did way too many things. And in fact, we had one component called the data fetcher. And I won't even try to explain to you everything that that thing did. And you know, I think this is actually a good representation of it because it had these tentacles that would wind their way through the code base. So, as a result of all these things, our code was really difficult to reason about, and we had really strange bugs to deal with. So tickets that looked like they should be simple were actually quite difficult, and would take a lot longer than we had budgeted for. Now, about a year ago, that code base was rewritten by a developer who came to us with a lot of Ember experience, and I carefully read each PR as he was rewriting it. And I'm happy to say that we now use established patterns for writing our components, and our code base is easier to understand and debug as a result. Of course, it takes time to think about and write better components, but because of my experience early on, I feel very deeply that code craftsmanship is extremely important. And to bring that home, I'd like to share a quote with you from the book Clean Code. And that is that the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easy to read makes it easy to write. And that's the crux of why I'm giving this talk. It takes energy to think about and write components that other developers in your future self will find easy to understand, and my goal for this talk is to give you some tools to help you out with that. So I'll start by explaining how you can keep things manageable, so you don't end up with giant one-stop shop components like we had, or a lot of redundant code. Then I'll talk about the characteristics of some useful Ember component patterns and go over an example of each. Then we'll turn our attention to writing the component's interface. And finally, we'll go inside a component to discuss managing your UI state with declarative rendering. So let's get started by talking about how we can keep things manageable. First, I'd like to briefly touch on the single responsibility principle, which, if we apply it to components, says that each component should be responsible for one concept. That concept could be quite simple, such as displaying a list of links, but it could also be more complex, such as a navigation bar component that includes multiple dropdowns that each contain a list of links. So if it's a complicated component, you'll want to break it down into smaller components that manage each piece of its functionality. Next, I want to talk about the don't repeat yourself principle. Basically, it's exactly what it sounds like. You should strive to eliminate redundant code. Duplication, or rewriting the same sections of code over and over again, is a problem because it bloats the code base, it leaves more places for bugs to hide, and it forces you to make changes in multiple places when requirements change. And let's face it, we work in web development, so requirements always change. And here I'd just like to point out that writing reusable code is important, but you want to make sure you don't write abstractions too early, because you could end up with the wrong abstraction if you do it too soon. A good rule of thumb, if you find yourself writing the same or very similar component sections several times, is that that's when it's a good idea to extract that bit of functionality into its own component. Then every time that piece of code is needed, you just use the component instead of rewriting the code section again. Which brings us to talking about some Ember component patterns that you can use to break down a larger component. We'll start off by talking about the reusable component pattern. Above all, for a component to be reusable, it should not mutate data that it doesn't own. And this is because when other developers use your component, it should pretty much do what they expect. There should be no surprising side effects. And I don't know about you, but if I used a component called color picker to try to change the font color, and it changed the background color of the page, I'd be pretty surprised. So in order to refrain from mutating data it doesn't own, a reusable component uses pure data down, actions up. Data flows down into the component as individual configurable properties, and instead of mutating that passed-in data inside of the component, it exposes an action that can be handled from the calling context. So let's look at an example. Let's say we're building a commercial space travel app that allows people to apply to go to the moon. Here we have a small section of a date picker that's used to select your launch date. In the calling template at the top, we're passing in the launch date as start date. And inside the date picker's template file on the bottom left, we have a series of buttons that each represent a day in the calendar. And if the button's day property matches the start date, we add an active class to that day button so the user knows that that's the launch date they've selected. When a user selects a new launch date, we have an update date action that's called inside the date picker's component file on the bottom right. So instead, it calls the update date action does not update the date itself because it's going to be reusable and it can't mutate that data for itself. So instead, it calls the passed-in onSelection action using this onSelection, and the calling template at the top handles the response to that action in the update launch date action defined in that component's component file. So because this date picker uses data down, actions up, and doesn't mutate data it doesn't own, we can also use this if we want a different date picker instance to choose a return date, say, as well. And the component wouldn't conform to other developers' expectations when they use it for that purpose. So next, what if you have a component you know that you're only going to use once? That brings us to a single-purpose component pattern. As you can likely infer from the name, this type of component has a single, clearly defined use case in your application. And this is very important because it gives us a couple of benefits. First, the fact that you only expect to use it once means that you'll know ahead of time the context in which it will be used, and the component can therefore be aware of that context. You don't need to pass in individual model properties, and you can instead simply pass in the model itself. Second, because of that contextual awareness, you can mutate data. You can mutate the passed-in data directly inside the component because it's aware of the type of model it's dealing with. So let's look at an example. Here we have a stripped-down edit user form. And at the moment, we know that this form will only ever be used to edit a user model. So in the calling template at the top, we pass in the model as user, and that's it. In the edit user form's template file on the bottom left, we have some inputs to the first name, last name, and password that are bound to their respective model properties, and we access them from the user model we passed in. We also have a save button that executes a save user action defined in the edit user form's component file on the right, and that save user action directly mutates the data by calling the save method to persist the user's changes. The edit user form can directly mutate the data instead of delegating the response to a passed-in action because that component is aware that it's dealing with a user model. If we instead had passed in a save user action to be handled in the calling context, we would be communicating to other developers that this action is configurable, which would be confusing. It's easier and clearer for a single-purpose component to mutate the data for itself. And before we move on, to other component patterns, I'd just like to point out that this idea of single-purpose and reusable components exists on a continuum. On one end of the spectrum, we have these highly reusable components that are pure data downs actions up in their implementations. And a lot of add-ons tend to use this because they're designed to be reusable. On the other end of the spectrum, we have these single-purpose components that are only used once, such as the edit user form we looked at, and are very domain-specific for your application. But many components are hybrids of the two. For example, if you have an edit user form, you likely also need a new user form in your application. But you don't necessarily need these to be separate components. If the two forms share most of their functionality with some small differences, you could rename the form to just user form, and then it could use most of the qualities of a single-purpose component, but it could also expose a couple properties to make it, to handle the small differences between them. Next, I want to talk about the provider component pattern. This is a type of reusable component that is only concerned with how things work. It might load data, execute logic, and define some actions that you want to use in multiple contexts. So that seems pretty normal for a component, right? But what makes provider components special is that they provide that data or behavior to be consumed by other components that call the provider. It does this by using the yield helper in the template file to return data and behavior from the component that you want other components to have access to. The calling templates can then access those yielded values via a block param. This can be a bit difficult to wrap your head around at first, but what really helped me grok it is imagining that the component is a function and the yield as a return statement. So it's as if you're just returning a value from a function that can then be passed into another function, which would really be the calling template here. So a provider component is also known as a renderless component because it doesn't render any markup or deal with styling. So it has no HTML or CSS. Of course, Ember components render a wrapper div for all components by default. So to make a provider component, you have to set the tag name property to an empty string in the component file to prevent Ember from rendering that wrapper div. The big benefit of this is that you can then call the provider component from anywhere and have access to its data and behavior without worrying about wrapper divs interfering with the layout of your calling templates. So let's look at an example. Here we have a very basic provider component that we've named %complete. In the component file on the bottom right, you can see that we have a computed property called percentage that depends on two passed-in properties, completed and total. And then it simply calculates the percent from those values. In the component's template file on the bottom left, it then yields or returns that percentage property to be used in the calling templates. At the top, you can see that we're actually using this in two different places. We're using the percentage property we're using it in two different calling contexts. A user application that we can imagine shows a fun moon graphic on the top left with a shadow that shows how far along a user is in filling out their application. And we're also using it in an application status component that displays a progress bar to show the user where the company is in evaluating their application. So let's now turn our attention to presentational components. This type of component is only concerned with how things look. They only render HTML and styling, so you can pass this component some data that you'd like to display in multiple ways, but it only uses that data to deal with UI state. It doesn't deal with or load any data. So here we have a section of a simple presentational component example, and we'll take a look inside the progress bar component from the previous example. In the calling template at the top, we can see that we're passing in the percentage from the %complete provider component as %completed. In the progress bar's component file, on the bottom right, we can then create a computed property that depends on %completed to set the filled width of the progress bar in the template file on the bottom left. Okay. The final component pattern I'd like to talk about is the contextual component pattern. This type of component is primarily concerned with making relationships between related components explicit to make it easier for consumer components to use them. It does this by providing default behavior out of the box that they don't have to configure for themselves. But they should only be wired together, you should only wire together components that share data and/or behavior. And a good indicator that you might want to use this type of component pattern is if you have a group of nested components that are always used together and share one or more of these things. So how do contextual components get wired together? One component yields a hash of related components that can then be accessed in the calling template with a block param, similar to the provider component pattern. But because it yields a hash, aka an object, you can access the components in the calling context with dot syntax as you would an object's keys. So, on to the example. This is a bit complicated. So here we have a modal. And let's say you have multiple modals in your application that share the same styles. That need to have a header, a body, and a footer, or some combination of those components. And they all have a close button in the header and a cancel button in the footer. So they all need to have access to this action as well. So first, let's look at the top right, where we have the modals template. You can see that we're using the yield and hash helpers to return an object of components, each called using the component helper. The header, body, and footer are pre-styled, which you can see in the bottom right of the modals component file. And we also have a close action that we need in 3 different places. We're using Ember modal dialog, which allows you to configure a close action that's triggered when you click outside the modal. And we also use that action in both the header and the footer. In the calling template, where we're using this modal component, we use a block param, we're arbitrarily naming m, to access the object of components we returned from the modals template. Then we can access the header, body, or footer components using dot syntax. And so here we're calling the header with m.header and giving it a customized title. And we're doing the same with the body, but we're actually inserting the edit user form component that we looked at earlier to display in the body. We do have to configure the close action in the calling context, but we only have to do it once instead of doing it 3 times. So turning the modals sections, the header, body, and footer, into contextual components gives us a few benefits. It makes it easier on the developer using these components because it gives them that pre-wired close action for closing the modal in different ways. And it communicates to them very clearly that these components are related and that they're always used together. Okay, so now we have an idea of some common Ember component patterns we can use. Let's talk about actually writing our components. There's an excellent technique called Wishful Programming, in which you first write some code in the calling template that uses the component before you implement the component itself. So I'd like us to ask ourselves, in an ideal world, what would my components interface look like? This will, of course, depend on the type of component or components you want to create. If it's a reusable component, you might write an interface that passes in individual properties and actions, so it's configurable. If it's a single-purpose component, you might want to write an API that simply passes in the model, and so on with the other component types. But aside from the specific guidelines associated with the different component patterns, when writing a component's interface, there are a number of questions we can ask that will help us discover its shape. So to get to this wishful thinking mindset, try a little empathy. Imagine yourself as the future user of the component and ask yourself some questions. What, if anything, will I need to configure to use this component? What do I expect this component to depend on? And what do I anticipate needing from this component? Now here it's important not to be too greedy as a prospective user or too eager as the developer of the component. You want to expose the bare minimum that you know will be needed. There's an unwritten rule in programming that any feature a developer can use, some developer will use. And every property you provide is a feature that can break when you need to make changes. This is the mantra of backwards compatibility. Once you promise functionality, it's hard to take it back. So the smaller your component's interface, the better. So finally, I want to talk about managing UI state and how using the principles of declarative rendering will make your code easier to reason about and prevent strained UI bugs from creeping in. First, to make sure we're all on the same page, I'd like to briefly explain the difference between declarative and imperative code. Declarative code, well, declares the intention of what you're doing. For example, a JavaScript array filter method is declarative because it tells you exactly what it's used for. Its intention is to filter something out, and it wears that right on its sleeve. The person using it doesn't have to worry about how the filter method is implemented and doesn't have to read through any steps to figure out what it's doing. By contrast, imperative code is concerned with the detailed steps needed to perform a task. A good example of this is a for loop, in that you have to write out the individual steps to implement some code. So you could implement the filter method with a for loop, but in order to understand what it does, you'd have to read through each of the steps, which makes it more difficult to reason about. Okay, so now that we have this distinction, let's talk about what declarative rendering is and how it can help you write easier to read and reason about components. Declarative rendering is an approach for writing user interfaces that makes UI state easier to manage by using the declarative nature of handlebars. Before my team started using this approach, there were a number of places in our code where we had weird bugs, like not being able to dismiss tooltips, for example. And we'd have to attach event listeners and remember to detach them. And we used a lot of lifecycle hooks to try to fix these bugs. This really bloated the code base and felt like we were playing whack-a-mole with our UI bugs. So luckily, declarative rendering declarative rendering is actually pretty simple. It's just a set of 3 rules to follow. The first rule is to make all of your component state explicit by declaring it inside the component file. You don't want people to have to jump around between files or dig around inside of your component to understand what state it deals with. So it's a good idea to declare all of your state together at the top of the component file. That means that you should declare any passed-in properties to the component from the calling template, as well as any properties that you set somewhere within your component. The second rule of declarative rendering is that you need to ensure that all of your rendering is a pure function of your declared state. In other words, your declared state should be the single source of truth for any changes your component makes to its state. Meaning you should never, ever rely on the DOM for your state. If you do, you open up your code to these strange UI bugs because you no longer have that single source of truth. So the third and final rule of declarative rendering is to make sure that your component re-renders when any of the state changes. And luckily, Ember makes this quite easy. It boils down really to just making sure that you use computed properties that depend on all of your declared state properties. If you do this, Ember will be able to recalculate the computed properties whenever any state changes. Any state it depends on changes, which will trigger it to re-render your component and keep everything in sync. Ooh. If you follow these rules of declarative rendering, Your code will be easier to read, reason about, and write. And you won't end up with those strange UI bugs that make you play whack-a-mole and bloat your code base to fix them. Oh, sorry, I got my clicking all off. So I know that this is a lot of information to cram into a 30-minute talk. And if you'd like to learn more about Ember component patterns or declarative rendering, the guys over at EmberMap are excellent at breaking down difficult concepts, and they even have a free email series on building better Ember components and the fundamentals of UI development. So you should check them out. Thank you all so much for listening, and I hope you have some more tools to help you think about and write clearer and more useful Ember components.